Hey, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 1, Lesson 2. We are once again exploring quadratic patterns and modeling them with equations. Starting off with a warm-up here with adding and multiplying binomials. So like in that last video I talked about, binomials means it has two parts. So it's usually split by either an addition sign or a subtraction sign. So you've got, a coefficient and a variable is all one part because it's all combined, it's all together. So with 2x and a 7, those are two different parts, makes it a binomial. So we're adding this binomial plus this binomial. All you have to do is add the like terms, just like we've done in the past for evaluating expressions. You're going to combine the like terms. 5x and 2x makes 7x. 7 plus 3 makes 10. Once again here, 8x and 3x makes 11x. 3 and negative 4 is negative 1. So you remember when you're adding things with different signs, you subtract the numbers or the absolute values of the numbers and then take the sign of the bigger number. Once again, if you're having trouble with integers, just use a calculator. 6x plus x makes 7x. Negative 1 and negative 10 makes negative 11. 12x and negative 4x is 8x. Negative 3 and 3 makes 0. Now, I could put 8x plus 0, but since it's not really necessary, I'm just going to leave it 8x. Negative 5x and 7x makes 2x because this number is too bigger than this. And negative 13 and 2 makes negative 11. So, alright, so that's it for the addition problem. So now we're going to do some multiplication. And you're going to use a process that you might not have heard before. It's called the FOIL process. And it's an acronym. It stands for first, outer, inner, and last. Sorry, it's not writing that very well. First, outer, inner, last. So basically, when you look at your terms, the first ones are the ones that come first in their parenthesis. The outers are the ones on the outside edges, the inners are on the inside, and then the last are the things that come last. Now basically FOIL is just a way of multiplying a binomial times a binomial, but really all you're doing is multiplying everything in one parenthesis times everything inside of the other parenthesis. Now you can either do it in the FOIL method, or actually you can do it in any order that you want. So if you want to do LOIF, or OILF, it's all the same thing as doing FOIL. It's just that FOIL is going to have you have your answer in standard form. So it's easier to do FOIL because then you won't have to change it to standard form at the end. Typically. I mean, it depends on your problem, of course. So 2x times 5x is 10x squared, like we've done in other videos. 2x times, so outers, so that'd be 2x times 3 makes 6x. Inners, 7 times 5x makes 35x. And last, 7 times 3 is 21. Now, I can then combine the two like terms in the middle. 6x plus 35x makes 41x, and bring everything else down. All right, same thing with this one. So we've got first, outers, inners, last. First is 24x squared. Outers is 32x. Inners is 9x. And last is 12. I'll combine the like terms on the inside, which is 41x. And I'm done. Alright, last question. I'll change colors so you can tell the difference. First is 6x squared. Outers is negative 60x. Inners is negative 1x. And last is positive 10. Combine the like terms in the middle and you get negative 61x, and bring your other terms down like we did in the past. Alright, so now let's get to the actual lesson itself called I Rule. And in this lesson we're going to once again explore patterns that are both quadratic and non-quadratic and be able to write and model them as equations, both recursively and explicitly. So when we look at this pattern, I count the blocks. We got 3 here makes 6. This is 7 blocks. This one is 5 makes 10, plus 2 makes 12. 1, 2, 3, 4, 5, 6, 7. So that's 14, 15, 16, 17. So I can already tell that it looks like it's a pattern of plus 5, which tells us, if it has a common difference, that we must be dealing with a linear equation. Because anything that has a common difference has a linear equation, because it's being added by the same amount every single time. So this one I can tell is going to be 17 plus 5 makes 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 if you count both sides. 20, 21, I'm sorry, 19, 20, 21, 22. So it is 22. So that is also plus 5. So if I was going to model that with an explicit formula, that would be y equals a common difference of 5 plus a starting point. If I was going to go back to the 0th term, that would be 2 blocks. So 5x plus 2 would be the explicit formula. The recursive formula would be starting point. F of 1 is 7 blocks. F of any number is found by taking the previous term and adding 5 to it. Okay, so that's all really a review of what we had done in the last unit, because that was a linear equation. So now we're going to look at this new pattern, which looks the same. It's a block again, so it's another letter I as a pattern. But what you're going to notice is that it's going to get really big really fast, because this one's going to be a quadratic pattern, and quadratic patterns get larger much quicker, or they get smaller depending on, we'll talk about that later, about quadratics can actually go decrease as well. So this one is 3, 6, 7 blocks, just like it was before. So we got the same starting point. But then you're going to notice that the blocks get blockier. And I know that's probably not a word, but that's actually what it says here on the lesson. They get blockier, meaning that they're getting larger in every spot. So they're I don't know how to explain that. They're just getting blockier. So then this is 4. I'm going to break it up into groups of blocks. So this is 4 in this group, and then there's another group here of 4 and another group here of 4. And what you should notice is that there are 7 groups of 4. And then when you look back at the first logo, it was 7 groups of 1. And if you look at the third logo, it's going to be 7 groups of 9. Now that's going to help me write the explicit formula, because what I am noticing is that the amount in each of those groups is always whatever size it is times itself. So if you multiply x times itself, that'll always tell you how many blocks are in each of those groups. And there's always 7 blocks, so the explicit formula will be 7 times x squared. So if I was going to use that, I could use that explicit formula to now solve any question. So when I ask you for the next one, draw size 4, I could simply draw it by making blocks of 16 in each of the 7 blocks, and then that'll be your logo. So it'll be whatever 16 times 7 is. 16 times 7, 42, 7. Looks like it's going to be 112 blocks total. All right, so we'll skip to the mathematical logo. So I already talked about the explicit formula. The recursive formula, we watched the last video. I did show you an example of that. We'll do more of that in the future. Compare the models. So comparing and contrasting, so they both have patterns. That's one thing that's similar. But what was different is one had a second difference and the other one was a common difference. Common differences makes it a linear equation, and second differences makes it a quadratic equation. All right, so the homework today is comparing area and perimeter of these shapes. And they're giving you polynomials and monomials and binomials, which are all polynomials, as your side lengths. Perimeter, remember, is the distance around a shape, where area is how much space it takes up on the inside. So if each side is x, and the perimeter would be 4x, because all 4 sides of that square are all the same. So there's 4 sides total, so 4x is the total perimeter. The area would be multiplying the length times the width, which you've probably learned a couple years ago. So that would be x squared. Multiply them. All right, so the next problem, problem number 10, we've got a binomial for each of the side lengths of the square. X plus 1 plus x plus 1 plus x plus 1 plus x plus 1. That's 4 x's and 4 1's. So that's 4x plus 4. The area, we're going to use the FOIL method, which is what we did in the warm-up earlier. That's going to give you x squared plus 1x is the outers, 1x is the inners, and 1 is the last. So that's going to end up with x squared plus 2x plus 1. Question 11 looks like a monomial times a binomial. So we're going to use the distributive property, which is the warm-up from 2 lessons ago. A times a is a squared. I'm doing the area first. And a times 5 is 5a. Last but not least, we got to do the perimeter first. So we got a plus 5 along the top and the bottom. So that makes 2a plus 10 if you combine these. And then if you combine these two sides, you get 2 more a's. So that would be a total perimeter of 4a plus 10. Last question. This is also a monomial and a binomial for it's a rectangle. The perimeters would be 1, 2, 3, 4 b's and 2 3's, so that would be 4b plus 6. And the area, use the distributive property. B times b is b squared, and b times 3 is 3b. All right, so that looks to be it. Please give it a like if I helped you learn something, and subscribe if you haven't done so already. Thanks again for watching. Have a great day.